The new high-performance telescope demonstrates to us through a very basic observation that our previous cosmological models must be flawed. The theory of the Big Bang and the idea of expansion as we have imagined it up to this point are not. Complete that much is certain. It's amazing how a simple result from James Webb has shaken up cosmology. We are at the beginning of a cosmological turning point. Which recent hypotheses are the best, and are we actually getting any closer to understanding the universe? With its cutting-edge technology, the James Webb Space Telescope, or JWST for short, was constructed to provide us with previously unheard-of insights into the early history of the universe. The JWST allows for observations that are significantly more extensive than what the Hubble Space Telescope can do. The JWST's large segmented primary mirror, which has a diameter of 6.5 ME and is nearly 3 times larger than the Hubble telescope, is one of its key features. It is composed of 18 hexagonal segments made of beryllium and coated in an extremely thin layer of gold. This design enables the JWST to gather a lot more light, enabling it to observe objects that are fainter and farther away. Another technological achievement of the JWST is its position in space. James Webb is situated at the so-called second Lagrange point, which is around 1, whereas Hubble is in low Earth orbit, 5 million kilometers from Earth. This location provides astronomers with a number of significant benefits. The site offers a steady temperature condition that is ideal for the sensitive infrared instrument of the JWST, and the telescope can continually observe cold and black space without being distracted by the heat and light of the Earth or the Moon. With its cutting-edge instruments, including the near-infrared camera, the near-infrared spectrograph, and the mid-infrared instrument, James Webb is best known for its ability to observe the universe in the infrared region of the electromagnetic spectrum. This enables researchers to see through dust clouds and study the formation of stars and planets that remain hidden in visible light. The JWST can also analyze the chemical composition of the atmosphere, detect exoplanets, and look for signs of life. We can now investigate the physical and chemical characteristics of distant galaxies, stars, and planetary systems with previously unheard-of precision, thanks to James Webb's ability to capture the light of the first galaxies to form after the Big Bang. Unbelievably, a single outcome can alter everything. The new superstar telescope hasn't even needed to employ its full potential to shake up cosmos. With its tremendous resolution and high-precision infrared equipment, it was a straightforward exercise that validated a big mystery of astronomy. When James Webb discovered that the so-called Hubble voltage was real and not a measuring error, the scientists abruptly understood that their earlier cosmology could not be accurate. Webb had measured the universe's rate of expansion. There is still a sense of powerlessness after a century of astronomical effort was in ruins. The Hubble tension is the difference between the universe's observed expansion speeds, which is brought about by 2 distinct approaches. Standard candles are astronomical objects with known brightness, like Type 1a supernovae or Cepheid stars, and the cosmic microwave background is thought to be an imprint of the Big Bang. On the one hand, the local measurement is based on the observation of standard candles. On the other hand, the cosmic measurement is based on observations of the cosmic microwave background. James Webb observed seeds in far-off galaxies with previously unheard-of accuracy using its sophisticated instruments. In addition to the seeds, Saids are stars that pulse at regular intervals, and the period of their brightness fluctuations is directly related to their absolute brightness. Astronomers can determine the distance to these stars and consequently to their home galaxies by measuring the stars' periods and apparent brightness from Earth. In addition to providing extremely dependable light and distance readings, the just observed Type 1a supernovae. These supernovae have such uniform luminosities that the observed values act as pillars that enable measurements of the universe and, consequently, the expansion rate. The expansion rate of the universe has now been calculated once more using precise data from the James Webb Telescope, and the results show the same increased expansion rate as the Hubble Space Telescope determined in the 1990s at about 73.4 kilometers per megapark. This contrasts with the roughly 67 km per Miapi Park, found by observations from the CMB and the Lambda Cold Dark Matter model. If our theories and the concept of standard candles are correct, the measurement should be the same in both cases. Planetary destiny is transforming us. We humans want to know the origins and mysteries of the universe because we want to know what the universe is, who created it, and what role we play in it. Let's take a moment to think about the current, general worldview, which assumes that the universe has a starting point and that it will likely end at some point. Can you imagine that cosmic destiny depends on a few measurement results? In essence, it doesn't. In other words, cosmic destiny is what is, and the cosmos probably doesn't care too much whether we measure correctly or not. In contrast to the notion that the universe may be endless, or that it is merely one of many universes within the multiverse, science currently holds that nothing existed before the Big Bang, and consequently, that nothing will exist after the universe. The way we view the world directly affects how we assess ourselves and our own lives. As of right now, astrophysics is like a jigsaw puzzle. Many pieces have been put together to create a somewhat coherent picture, but the Hubble tension indicates that something is amiss. It's like a piece that simply won't fit and ruins the already finished picture. James Webb revealed further issues that are disrupting the game. This is where the Hubble tension comes into play again. If our measurement techniques are flawed, or if we have missed something crucial, our age determinations of the entire universe may not be accurate. Thousands of brightly shining galaxies at a time when the universe should still be dark are so developed that their time of formation must have been before the Big Bang. The universe is infinite in time and space after all the Big Bang and starting point took place at a different time, or the nature of the universe is completely different from what we have seen so far. Imagine what it must have been like when people still thought the Earth was a disk, and when you get to the edge, you might plummet into nothingness. That had an impact on the mindset and psyche of the people of those eras. They were afraid to move towards the horizon, because that is where the world supposedly ended. As a result, people remained more static, moving less. Can't staying in one place for safety reasons today. We believe that the universe is finite. Suppose we find out that it's infinite. Then our mental concept of time and space will change, and that will have an impact on our behavior as a species and our culture. Even if you are a non-scientist, you have the old cosmological ideas in you because we all learn the idea of the Big Bang and expansion in school in Eastern traditions and religions. People believe in a multiverse in which there are many dimensions with humans. These concepts, gods, demons, angels, and natural creatures, are strangely mirrored in physical models like Burkhardt-Heim's multidimensional universe and string theory. According to Sir Roger Penrose's cyclical universe theory, which is currently gaining traction, our universe may have begun, evolved, and then died in order to recreate itself. This theory is also supported by some spiritual theories that suggest a soul that undergoes multiple incarnations. If the principles of eternal psyche are found to be more and more supported by the scientifically observable cosmos, it will have a significant impact on how we assess our own fate and the significance of the cosmological crisis in our lives. The future will belong to researchers who are happy about such changes and who have a genuine interest in the truth and not just want to be right. We already have some exciting new theories, and it's almost like science is being redrawn. When Columbus sailed around the world and proved that it was round, some people were shocked. The church flatly refused to acknowledge the new knowledge, and some people rejoiced. We have exactly the same situation today, with some people being happy about the shocking measurement results on the web and others refusing to acknowledge it. Rendra Gupta, an instinct researcher, has written a paper re-evaluating the universe's age. If Roger Penrose's notion of a cyclical universe is proven correct, or quantum physicists gain traction, he could receive a second Nobel Prize. The JWST went into service 2 years ago, and it will be with us for at least another 20 years. Even the old Hubble Space Telescope is still in service and is landing incredible hits in spring 2022. Hubble succeeded in finding the oldest single star ever sighted. This star became visible by chance, and a huge gravitational L-web will make further observations of the early universe and we will see more and more details. Already the telescope has provided further evidence of structures that could not possibly have existed in a young universe behind the Pandora cluster. Which is a huge structure in itself, the telescope found evidence of a much older and even more gigantic structure. This shows that in the universe we consider to be young, there have already been structures so large that they go beyond our cosmological models. Webb also discovered very old and very large black holes, only a few 100 million years after the supposed Big Bang. These black giants combined the mass of several million or even billions of suns. But how can this be if there couldn't have been much matter at that time? Get the channel today to see a ton of more fascinating videos.